Hello everyone. I am doing first lab of the Iolab application, the one using the Iolab device, okay, which is introduction to Iolab. So for this you will need to have Iolab software installed in your computer, laptop, okay, Mac, and the Iolab device itself. So if you don't know how to install the software, you can let me know, contact me with the email which I'll be giving at the end, okay. So if you have your iLab software installed, and you should see the screen like this, and if you have the lab files aggregated into the system, okay, so you will go here and you will find your labs over here. Okay, so there are a list of labs and homeworks for you here. Okay, so we are doing introduction to our lab. So first lab, so you can just click it here. Okay, this will bring to your first lab one, introduction to Iolab and software itself. Okay, so if you are working individually, just write your name. If you are working in a group, you write your group name. Okay, so for now I think we are working individually, so make sure you can write your name here. Okay, the important thing is what I want to mention here. Okay, so please check the device. Okay, let me show you the device. So you should have the device coming into this box here, kind of this box. Okay, and the device will look like this one. Okay, it will look like this one. Okay, that's on your head, so you can see here. Okay, one interesting thing to point out here is you can see the difference in the direction of positive y-axis here in the software, okay, which they have considered. You can see the software and the direction of the y-axis here. Okay, if you see in the device, the direction of positive y-axis is going from single wheel towards the double wheel. Okay, it's going up. But you see in the software application, the file has been written in such a way that the positive y-axis is going from double wheel towards the single wheel. Okay, so while doing the experiment, we will consider the positive y-axis is going from double wheel towards the single wheel. Okay, so the positive y-axis in this device would be considered going from double wheel towards the single wheel. Okay, the reverse of that one, it should be going from double wheel towards the single wheel. Okay, that's the important point, because the lab in the application software has been written like that. So we will, while doing the experiment, again we will be considering the positive y-axis is from double wheel towards the single wheel. Okay, double wheel towards the single wheel. Okay, let me minimize the screen here. Okay, after that one, okay, if you see, okay, let me see, slide one. So you can write your name, or you already done. Now then you can click save and go next. Okay, first one, now you can see you need a dongle, and these are the Iolab device. Okay, remote one and report two. We don't need two of them, we already have one. So dongle is something like this. Okay, it will come when you get the device, when you buy the device or rent the device, it should come by itself. Okay, and you have to put it into the USB port of your computer, USB port of the computer. If you do not have it in the Mac, you need to get one that allows you to control the, you see the dongle, it popped up, it was not lighting in the beginning. Okay, and for the Iolab device, you can turn this PowerPoint on, then it will be popped on. And the next thing, like when you get the Iolab device for the first time, there will be a plastic wrap either here or here. Okay, that will be making the connection of battery, like disconnecting it from the software, so that it will not run when in the beginning, yeah, when it's new. So you can take that plastic wrap out by unscrewing this one and take the plastic wrap out before turning it on. Okay, and then you can turn it in on. You can see remote one will be paired. Okay, you can see the remote one is paired now. This one is paired in the software. Okay, next thing, insert the, we did that, we inserted the dongle. Yeah, we turned the Iolab on, place the Iolab at flat smooth surface, so on they can use the table. For now I'm using the wood. You can use the table also. Okay, since we have to tilt it after some time, I'm using the wooden board for now. Okay, so the table wheels down, so you can see the wheels are pointing down. Graph to the right is tilted title velocity. So this is the graph they are talking about, the one title velocity. Okay, and then click the record button. So the record button is right here. Okay, first thing, what you can do is, okay, so you can put the Iolab device pointing down, okay, pointing the wheels pointing down, okay. You can point like this, anywhere you like, okay, it's up to you. And they want us to use the record button and graph record, move the Iolab to the right in the direction of the y-axis. So they want us to move the direction in the y-axis, okay. Positive, that means the positive y-axis they have indicated from double wheels toward the single wheel, okay. That is the positive y-axis. So as Andrew said, it's given in a different direction in your device, but we are using the one the software is recommending, okay. So double wheel towards the single wheel is the positive y-axis. So if you want to move it from here, you have to put it like this. Double wheel towards the single wheel, you'll remove it like this. If you want to start it from here, okay, let me start from here. Double wheel towards the single wheel, okay, that will be a positive y-axis. Double wheel is this side, single wheel, so positive y-axis is like. So let me point it here. Now they want us to click on record button, okay. Record button. They want us to move us towards the positive direction. Sorry, let this stop it again. Like, okay, let me teach you this thing, next thing also, okay. So if you like happen to put record one by mistake, you can remove that recording also, okay. Just you can just click on remove, and so you can start from again, okay. So I'm just trying to show you the graph also while recording, okay. So let's start the record, okay. Record button, and I will start from here, okay. So it's not moving right now. I move towards the positive side, I go back toward stop and go back toward the negative side as indicated, okay. Then we can stop the recording, okay. Let me check this one out, or I can minimize it for now, okay. So what they want after that is, what is the sign of the velocity when you move the Iolab in the direction of plus y? So as I've already said, plus y is the direction from double wheel towards the single wheel, okay. And that was the direction when I moved from double wheel towards the single wheel. It was in race, I was not moving. Then I moved towards like in the positive direction, of positive y direction. Then I stopped, that was 0 again, and then returned back in the negative direction. So this is positive sign of the velocity when moving in the positive y direction, yeah. So we can save and go next, okay. Measuring and graphing. So they want to graph the angular velocity. So the title is gyroscope, yeah. So they want to put the Iolab, okay. So let me turn the video on again. So they want to put the Iolab on the surface while the wheels are up, okay. They want to put the wheels being up, so you can put the wheels being up like this, okay. And then click record, uncheck the boxes omega x and omega y. So they are just trying to move it along, like rotate it along one axis, like one of the axis z, omega z, I think. Okay, click the record button, spin the Iolab, keeping it flat on the table. Try spinning clockwise, counterclockwise, and with changing speed. Okay, so let me do this one. Okay, let's click on the record button. Let me move clockwise. Okay, anti-clockwise, okay, slowly clockwise, okay, slowly anti-clockwise, okay. Okay, let's just it. Okay, now we can stop it. Okay, so after you stop it, let's do the analysis again. What is the sign of the angular velocity when you spin the Iolab clockwise? Okay, so I started with clockwise, yeah. It was when it was fast, it is negative, obviously. When it was this is anti-clockwise, counterclockwise, this is clockwise again, this is anti-clockwise. So with different speed, it was this with different speed, okay, but they were both negative when I spin them clockwise, okay. So what is, it was negative for the clockwise spin. Okay, then we can save and go next, okay. Okay, and the next thing is wheel versus the velocity, okay. Now they want to use, okay, so using a velocity graph. We'll velocity, note that the title of the graph, we already raise one end of the ramp with the blocks or textbook so that the ramp is roughly 15 to 20 degrees from the horizontal protractor, okay. I am using just a box for this one now, okay. Let me just show you. Okay, so what I can do is, okay, so I'm just using a box for now. Okay, so they want us to tilt the, like tilt it here. Okay, just tilt it. Okay, you can measure the angle with the protractor here. Okay, 15 to, it should be 15 to 20 degree. Okay, after that, let us okay, following the instruction, moving to the instruction. After that, they want us to hold the Iolab at the top of the ramp with the wheels on the ramp and y-axis pointing down. So again, as I have already said, y-axis pointing down means we are considering from double wheels toward the single wheel. Okay, so you should be pointing double wheel towards the single wheel and the ramp. So that's going pointing towards the positive y-axis. Okay. Okay. After that, so click on record, wait on a second, please, and release the Iolab and catch it at the bottom of the RAM. So let's do as it has been slayed. I'm going to record it first. Okay, click on record. Okay, and then hold for a second. Then you can leave it and just catch it when before it reaches the ramp. Okay, then we can stop it. Okay, after that, let's do the analysis part. This part is like tell you how to get the different values or tool using the graph tools. Okay, the tools available here. Okay, so after you're done, you can save and go next. Okay, now click on the magnifying glass. Okay, you can see magnifying glass here. Click on the top of this glass. Then they want us to click the part that we need. So this is the one. So this was when I was holding the Iolab. When I left it, it was moving in the ramp. Okay, positive slope, and then it comes back to the race with zero velocity when I stopped it. Okay, so let's do the magnifying thing using the magnifying glass. Okay, click and drag the cursor on the wanted section. We did that already. Okay, magnify the part. Click on the bar graph icon to the left of the magnifying glass, so which is here. Okay, at the top is click and drag across the section of the graph with a positive slope. So that's it starts from here. It has a positive slope up to this one. Yeah, so we have to start from here. Okay, so okay, let's select this region. Okay, starting up to this one. Okay, that's good. That's good. After that, okay, so here the symbol delta t, you can see delta t represents the time interval. Okay, they want us to write the time interval. Okay, which is 1.1 seconds. Yeah, 10 seconds. Okay, after that, they want us to use the average velocity. So the Greek letter mu is the mean or average of the data. Right now it's velocity versus the time. Okay, so this mu is giving the average, that's why it's mean velocity. But if it is different thing here, position here, it should be average distance, average position here. If it was acceleration, it would be average acceleration. Right now it's velocity, so average velocity is given by mu, which is 0.49 meter per second. Okay, 0.49 meter per second, and displacement is given by the area under. You can make it a little bit wide this side. Okay, but it was nearly, so I just kept it there. Okay, symbol A is the area under the graph shown in the green. In this case, this is the displacement. Okay, the displacement is 0.539 meter. Yeah, 0.539 meter. Okay, acceleration is the rate of change of velocity. Yeah, so the slope should put the acceleration. So the symbol S represents the slope in the graph. In this case, this is acceleration. So acceleration, yes, is 0.85 meter per second square, 0.85 meter per second square per second. So for the square, we can use this one. Okay. After that, move the cursor around the graph to obtain the velocity data at particular distance. So you can move, you can see, you can move the cursor here. So yeah, this is velocity and time at that instant is given here. If I put here 0.566, okay, it keeps on increasing. So what is was the maximum velocity of the Iolab during the run? So the velocity is being measured here. Maximum should be here. Yeah. So what was the maximum here? You can. Okay. So it should be 0.94 should be 0.96 is here. Okay, 96. Like while making like selecting the region, you might go up to here also. Okay, that was like I just skipped up to here. So 0.96. I think we reached 0.96 here. Okay, 9.96. I saw 96 okay, somewhere. Okay, 0.96. No, 94. 0.96 meter per second. And again the values will be different here. Okay, I did the experiment, so this was a different, like you might, while doing, you might leave it somewhere in 1 second, somewhere you might leave in 2 seconds. So the data will not be exactly similar when 2 persons to the lab, or even if I do the same experiment again, it will not be same. So be careful of that. Okay, so I can save and go next. Okay, now time to calibrate the force sensor of the Iolab. Okay, so okay, let me turn on the video again. So okay, just give me a second for that. Okay, for the calibration of the force sensor. Okay, so what you need to do is in the Iolab you need to put this. I think I pulled it already, like in the beginning also, but in the beginning it will not be there. While you buy it, it will come with the Iolab itself, the device here, but it will not be here. fine. You can put it here in the beginning also, but that's what I'm just trying to show. Okay. Okay, so this will come as a separate thing in your Iolab box itself when you get this one. Okay, and then to do the calibrations, you can just screw it down. I bolt device. Okay, take it from your box and you can screw it down. Okay, after that you can go. Okay, if you want. Okay, let me show you. You can just make it tight as possible. Just a tight. Okay, this will be fine. Okay, and next. Okay, so let me see here. They want. Okay, they want us to click in this thing. Okay, so calibrate the force sensor. So you have this here, the setting thing. Then you can click on calibration. Okay, next thing what I want to show you is you can see if you do the inactivity, the remote ID is gone off. Yeah, so it will, if you keep like long for inactivity, it will go off. So you might need to turn it on again. So just click on this thing here, power button, and it comes back again. If you can see, it's coming back again. Okay, after that, let's click on the sensor thing. Okay, click on calibration. Okay, I think video is disturbing, so let me put it down. Calibration. We are trying to do it for the force, so click on force. Okay, so it will guide us how to do it. So let me put it in the side. Okay, so step one, we already did that eyeball thing, yeah, and set the device on its head. So we can just put the device on its head right here, just leave it. Okay, and then click next. Okay, after that, lift the device by the eyeball screw into force probe so that it hangs at rest. Click on next and keep it for position for 2 seconds. So they want us to hold it here, and you can use the spring also, but you can just lift it like this way is also fine. Okay, just lift it and keep it at rest. Don't move it. Click on next and keep it for 2 seconds. Okay, and then it should be calibrated. Now you can save it after that. Okay. Okay, after that, it is calibrated. So after that, save and go next. Yeah. Okay, now they are trying to wait the Iolab and wait something with the Iolab device itself. Okay, so now you can wait the Iolab, click record, next hang the Iolab from the hook. You will see the force measured in second. You just measure on the way. So okay, so let's click record. Okay, clicks record. You can lift the Iolab on its head. Okay, you can see it's measuring the weight of the Iolab. Let's keep it back. Let's stop it for now. Okay, we can continue later on. After that, so it wants us to, you see in point 3 now, hold the Iolab with the hook pointing down and hang something from it. You can, for me, I'm using bunch of, okay, let me show you here. I'm just using bunch of keys right now. Okay, bunch of keys. They want us to hold the Iolab, point it down and hang something on it. You can use with the water bottle, sorry, you can wear the water bottle. Okay, anything like textbook, simple thing, but so you can just do that. Okay, I'm just waiting the bunch of keys here. Okay, so let me do that, and then if I continue to wait, so it should measure the recording. Okay, you see there's, so it is being measured. You can stop it. That's fine. I can take it out now. Okay, after that one, so it's not in it now. I can minimize it. How? What did you wait? Bunch of keys, yeah. Bunch of keys. How much did it weight? So the weight is right. This was for the Iolab, yeah. This thing was for the Iolab. Now we put it down. It went back like there was nothing. It went back to 0. Now after waiting for the bunch of keys, the value is right here. So what you can do is you can use your tool. Okay, see the value. You can average it actually, and the value was, how much is the average? 1.139 Newton. Okay, so you can just write 1.139 Newton. So that's it. Yeah, it seems reasonable. Yeah, for the bunch of keys, it was around half of the Iolab itself. So yes, it is. You can explain it in your own words. Okay, yes, it is REA reasonable. Okay, and then you can click save and go next. Okay, and let's move just to the, I think, okay, the second last slide. Kinds of motion. Now if you see here, they are doing wheel position, wheel velocity, wheel acceleration. Okay, set up a level at the smooth surface which you can easily tilt. So let's take this one out. Oh, sorry, let me take, sorry, this is free video. Okay, so they want us to create a smooth surface. Yeah, so should be the smooth surface since I have to tilt it. So let's do like this. Okay. After that one, ensure wheel is being graphed. Okay, so put the alive on its wheel. So you can put in any direction in the beginning. Okay. Okay, let me prove like this. Okay. After that, what they want is ensure wheel is being re-recorded. So we can record that everything is being recorded. Yeah, we have the dongle connected, remote connected. Okay, tilt your surface a little bit one way. The Iolab will want to run off the surface, stop it before it falls off. Okay, so they want us to just hit the record button. Okay, right now it's not moving. When I tilt it, but I need to catch it before it stops. Okay, I can catch it, let it stops, then I can stop it. Okay, if you are not satisfied with your data, you can, like as I have again said, you can remove it, like removing it. Okay, and then we can repeat the process again. Okay, so let me be careful and do the process again. Okay, as instructed, I will keep it in this here in the surface. Okay, and then let me click the record button so that I can click the record button. I'll just leave it for a second. I'll tilt it. Okay, and then I will stop it before it hits. So I will just keep it here. Okay, and then you can stop it. Okay, let's go to the analysis part now. Okay, so I think we did the experiment, so we can minimize the video. Okay, now, okay, so this is position versus the time. Yeah, so this is velocity versus the time, and this is acceleration versus the time. So this is when we started to, no, when this was in the flat surface, it was just keeping at rest. This is when I tilted the surface, it started to move. Yeah, and this is again when I stopped the Iolab surface. Okay, you can discover it after this part, or you can zoom also like this. Magnifying your required section also is up to you. Okay, I can just, okay, that was our required part, so it changed everything. So this was when it was still like not moving, the surface in the smooth surface. When I tilted this one, it started moving, changing position. Yeah, this is also same, it started moving. Acceleration, although comes little, but it's here. Okay, and this is when I stopped, it returned, position becomes constant, the velocity goes to 0, acceleration was negative for just a quick second, and then it's 0 again. Okay, so use the complete sentences. You have to use the complete sentences. You have to use your own words. Okay, I'm just writing it. So steady speed, is the speed constant? You can see it here. Okay, it's not constant, it's increasing. Yeah, so it wasn't, it is not, velocity is not, use your own words. Okay, and complete velocity is not steady but increasing with the time, using the ramp, increasing with time. Okay, like it is asked, like it was 0 in the beginning, then it increased with the time, and it became 0 again. Okay, but it is we are discussing it for the part when we tilted the surface. What was happening before you tilted the surface? Before you tilted the surface, velocity was 0. Yeah, it was before. You have to use your own words. Okay, and in complete sentence. Before tilting surface, it was at rest. It was at rest with 0 velocity. With 0 velocity, acceleration is also 0, position is also 0. Okay, what happens if you tilt the surface other way? If we tilt the other surface other way, the sign of the position, the what's it called, velocity and the acceleration will reverse. Okay, sign for the measured quantity will be reversed, like this velocity and measured quantity will be reversed. Okay, because we just, but we have to make sure, like this is how we put the, okay, let me show you the figure. Okay, okay, so this is how wheels were like double wheels towards the single wheel. Okay, we kept it like this. We did the experiment by tilting this software. Okay, if we were like, if you keep in the other side there, but the wheels, double wheels will pointing toward the, like that side. Okay, in the same direction. And if you keep it here, do it in the opposite side, it will, the directions will be reversed for the values. Okay, or the position, velocity, and the acceleration. You can save and go next. Make sure you write your answers on your own words, and for the graph, the results will be different if we do different person and different, like if I do it again, the results will be different. Okay, so be careful of that. You can save and go next. Okay, I think this should be it. So you can see the like video to how to save it, or I'll just quickly show it. Okay, you can save and go next. Okay, and then after that it may return to your lab report. So you can see the report is created. This is where I did it previously. Okay, so reports are created here, and then what you can do is, so you can write your name. Okay, well, you did the lab, so you can write your name, okay, and then save it. Okay, and then you might need to convert, like export as a PDF file, so that to submit. Yeah, so and give the name as you like. Okay, okay, next, how do I save it? I will save it somewhere. Okay, you can save in your location repair. Okay, just give the name you want. So I can save it. Okay, that should be done. Okay, and if you have problem installing the software or any other issues, you may email me at samin.sm@gmail.com. Okay, that's my email address. Okay, thank you.